Hi everyone, Carl Valeri with the FAASAfety team. I'm a lead representative here in the Tampa FISDO, and this is the topic of the month for May 2015, Aircraft Performance. All links mentioned in this video can be found at expertaviator.com, and also don't forget to subscribe to our YouTube channel, youtube.com/expertaviator. In this presentation, we'll talk a little bit about loss of control accidents and recommendations from a work group that studies loss of control. We'll talk about aircraft performance parameters and calculations. We'll also offer suggestions that will help you with aircraft performance predictions. Finally, we'll give you some tips and tricks that will help you to avoid performance-based accidents in any aircraft. Here are some findings of recent study of loss of control accidents. Most fatal general aviation loss of control accidents cite inadequacies in aeronautical decision making and a subset of ADM, single pilot cockpit resource management skills. Occasionally, investigations have discovered causal factors resulting from unreasonable expectations of aircraft performance, especially when operating at the edges of the aircraft weight and balance envelope. That's why the Loss of Control Workgroup suggests improvement in pilots' understanding and calculation of aircraft performance. When we speak of aircraft performance, we're usually answering three basic questions. How much can I haul? How far can I go? How long will it take me? It sounds simple, but an exquisite set of interdependent variables must be considered in order to answer each of these questions. Most of these variables have to do with aircraft performance, but the most important variable does not. A good way to plan a flight is to decide how much weight you want to haul to what destination. Start with crew and passengers, then add cargo. If these items alone exceed your aircraft's capability, you'll either have to make multiple trips or get a bigger aircraft. Once you know how much you want to haul, you can figure out how much fuel you can take, and that together with your weather information will tell you how far you can go. If you have enough to get to the destination, plus alternate, plus reserve, you're golden. If not, you have to plan an en route fuel stop. But wait, there's more. You'll also have to consider your departure and arrival airport's runway lengths, obstructions, and expected density altitude. If the field is short and or obstructed, you may not be able to safely fly with a full load. One more thing. Just because the book says the aircraft can do it doesn't mean that you can do it. Pilot skill and experience count for a lot when you're trying to duplicate Pilot Operating Handbook performance figures. So be conservative when you calculate your performance and consider adding a safety factor. Some pilots add 50% to their takeoff and landing calculations for safety. Now we can figure all this out by consulting the POH, right? Well, maybe not. There's one more huge variable to consider, and I bet you know what it is. So what's the greatest variable in all this? That's right, the pilot. Let's face it, the POH figures and all your calculations don't mean much if we can't duplicate them in our flying. That's why it's important to document your performance capability at least yearly with a certified flight instructor. Fly a typical mission, wait, and try to duplicate or simulate mission density altitudes. That way you'll know what you and your aircraft can do. In order to know what performance you and your flying machine are capable of, you'll need to establish a baseline. Think of your baseline as an omnibus reference that relates pilot and aircraft performance under a given set of environmental circumstances on a given day. Human factors such as fatigue, environmental factors such as higher density altitudes will result in performance below the baseline, while proficiency training and lighter loading will likely result in above baseline performance. The key point to remember is that for any given flight, you need to determine how you and your aircraft will perform. Your baseline is the foundation of the determination. Here's a sample baseline calculation sheet extracted from the Alaska off-airport operations. The guide is available at a URL below. I set one up. It's expertaviator.com/flyalaska. To establish your baseline, we suggest you load your aircraft with a typical mix of fuel, cargo, and passengers. We recommend that one of those passengers, of course, is your flight instructor. Calculate your test weight and note runway conditions, elevation, density, altitude, wind direction, and speed. Also note what rotation and climb speed you intend to use and calculate 70% of the rotation speed. We'll explain why this is important in the next slide. Next, you'll fly several takeoffs and landings, noting your performance on each trial. When you're done, you can average your performance figures and complete your baseline chart. Here are some rules of thumb when making takeoff calculations. If you have a fixed pitch propeller, add 15% to your calculated takeoff distance for every 1,000-foot increase in density altitude up to 8,000 feet. For constant speed props, add 12% per 1,000 feet of density altitude up to 6,000 feet. When planning takeoff from short, unobstructed runways, establish a landmark at 50% of your calculated takeoff distance. When on takeoff roll, you should have 70% of your rotation speed at that point. If you don't, the safest thing is to abort the takeoff and reduce weight, or wait for more favorable wind conditions and temperature conditions. In this example, we're assuming a rotation speed of 60 knots or miles per hour. 70% of 60 is 42, the number you'll want to see at the halfway point. If you must clear obstructions on takeoff, you'll need to have 70% of your rotation speed by the time you travel 30% of your available takeoff distance. You'll want to be stabilized on final approach with flaps full at 1.3 times the stalling speed in landing configuration. Don't cut your final short. Make it long enough to be stable and go around if you're unstable. By the way, the photos on this and previous slide are of an annual takeoff and landing competition held in Valdez, Alaska. We strongly suggest you don't try this at home without some quality instruction. Once again, the greatest variable is the pilot, but if you document your baseline performance at mission weight and density altitude and fly regularly with a CFI, flight instructor, you'll well on your way to safer flying and few nasty surprises along the way. Thanks for listening to this short presentation. You can find these presentations and more seminars at FAASafety.gov. And don't forget to visit expertaviator.com, where I will be putting more of these videos from the topic of the month. And if you get a chance, subscribe to our YouTube channel, youtube.com/expertaviator. Also, when you're at expertaviator.com, visit some of our other shows like Aviation Careers Podcast and Stuck Mike Gavcast about general aviation. Well, thanks again for listening to the topic of the month for May 2015, Aircraft Performance. My name's Carl Valeri. I'm here at the FAA Safety team in the Tampa FISDO. We hope you enjoyed this video. Fly safe. We'll talk to you next month